We'll be working with polynomial functions again today. We're going to talk about how to find the zeros of those polynomial functions, and this is part 1 of 3.4. So our objectives are to use the rational zero theorem to find possible rational zeros, find zeros of polynomial functions, solve polynomial equations, and then later we'll do the linear factorization theorem and Descartes' rule of signs. So this is the rational zero theorem, and there's a lot of letters involved. The main thing is it has integer coefficients, and P over Q is a rational zero of F, and then P is a factor of the constant term, and this will make more sense as we do some examples. So what are the zeros? So the zeros of a function f are the roots or the solutions of the equation f of x equals 0. So when you set it equal to 0, then you're finding the x's that make that equation equal to 0, which we've done a lot before. Also, the real zeros are called the real roots, and those are the x-intercepts of the graph. So we'll start by listing all the possible rational zeros of f of x equals negative x to the fourth plus 3x squared plus 4. So if you go back to that rational zero theorem, the main things were that P is a factor of the constant term so that's that number at the end. And then also Q is a factor of the leading coefficient which in this case is -1 out front, because you could put a 1 right there and that'd be -1. So the constant term is the 4, the leading coefficient is -1, and then the rational zero theorem said to take P divided by Q. Okay, so what that means is that we're going to be taking P divided by Q, which is, P is all the factors of the constant term and Q is factors of the leading coefficient. Okay, so let's look at the constant term. It was 4. So factors of that, you could have 1 times 4. You could have 2 times 2. You could also have -1 times -4, -2 times -2. So let's go ahead and write those out. We would have 1 let me go ahead and list it as -1, +1, -2, +2, and -4, +4. And now the leading coefficient was -1. So the only way you can get -1 is with a +1 and a -1. Okay, so another way that you'll see this written, you notice I have a positive and negative of each. So the top could have been plus and -1, plus and -2, plus and -4, and the bottom was plus and -1. So you'll see it written either way. So now if I reduce that out, let's go ahead and think of how we could do this. So I'm going to give myself a little room here. So if I take everything in the top divided by everything in the bottom, let's just go one at a time. -1 divided by -1 would be +1. If I did -1 divided by 1, then I'll get -1. So you could just say positive and -1 would be one option. If I did the next term, it would be 1 divided by -1 and 1 divided by 1. I'm going to get the same thing. So let's go ahead and jump to the 2's. -2 divided by -1 is +2. -2 divided by 1 is -2. So you're going to be seeing a pattern here. This is plus or minus 2. So you could also be looking at it down here. You know you could get a +1 or a -1 depending on which one's negative and which one's positive. Same here, you'll end up with a +2 and a -2. So now if I do one more here, because the 2 isn't going to be different than the -2. If I do -4 divided by -1, I get +4. -4 divided by +1 is going to be -4. So I get that plus or minus 4, which I would also get from the shortened version down here. So you're going to see shortcuts where you're not going to have to take this many steps on future ones. But in the end, what they want to know is all the possible rational zeros. So you can see there are 6 possible zeros. Either by looking at this list, you see there's 6, or this list, you have a positive and negative of each, so that also makes 6. So there are 6 possible rational zeros, and you could list them out either way, the long way or the short way. Okay, so now this one's already written out a little bit. So factors of the constant term. -2 is the constant term. Factors of the leading coefficient are 15. So now let's go ahead and list our factors. We'll try to do some shortcuts on this one now that we see how to do this. So the constant term, if you think of -2, I can make that with a 2 and a -1, or I can make it with a -2 and a +1. So you could have a positive or a -1 as a factor, or a positive or a -2. Okay, 15. You can make that with a 3 and a 5, or a -3 and a -5. You could also make it with a 1 and a 15, or a -1 and a -15. So if I combine those together, I have a positive or -1, positive or -3, and I'm going to put them in order from least to greatest. Okay, so now what we have to do is go ahead and divide that. So the first one's easy. You're just taking the top, this positive or -1, divided by the other positive or -1. So you could get a positive or -1 that way. Then if I take my top number, positive or -2, divided by positive or -1, I'm going to get positive or -2. Okay, so now let's go to the next set. If I do this, I could have a positive or -1/3. If I do this, I could have a positive or -2/3. Okay, then if I do the next one, I have a 5 now, positive or -1/5, positive or -2/5. And then our final one, getting a little messy here, positive or -1/15, or positive -2/15. Okay, so this one, I'd have 2 here, 2, 4, 6, 8, 10, 12, 14, 16 possible zeros since they all have a positive or a negative. So you'd want to list them, and then you could count to say there are 16. Okay, let's try 2B. Now this one, I'm just going to let you look at it in your notes on your own because it's the same process. I just wanted to provide another example for you, so I'm not going to walk through this one. It does go step by step for you to look back at. So we're going to skip to example 4. So the last ones we were just looking at all the possible zeros. Now we're going to find the actual zeros. Which ones actually make this, which x's are going to make this equal to 0. So it's going to be 3 different slides for this one. Factors of the constant term, our constant term is the -3. And then the leading coefficient is a 1. So factors of the constant term, you could have positive or -1 and positive or -3. Then on the bottom would just be positive or -1. So if you divide those out, the 1 divided by 1 could give you positive or -1. Then 3 divided by 1 could give you positive or -3. So now we're actually going to test these and see which ones actually do make it 0. So we're going to test the number 1, the number -1, the number 3, and the number -3 from this list here. So the easiest way to do this is going to be to do synthetic division. And we know if we get a 0 remainder, then that is going to be a 0 of the function. So let's refresh our memory on synthetic division. We're trying to divide by 1. In our constant terms, we have so I'm dividing by 1 here. I have a 1, a 7, an 11, and a -3. So we're trying to see if we divide this by, we're pretty much taking this divided by x minus 1. So we're taking this whole thing divided by x minus 1. Because remember, this has to be minus something. So if it's a positive 1, that just means I put a positive 1 out here. You can go back at the previous lesson if you forgot how to do the synthetic division. So I bring down the 1. 1 times 1 is 1. And I have to add this row. Then I do 1 times 8, which is 8. Add this row to get 19. Then I take 1 times 19 to get 19, and I get 16 as my remainder. So we know this one does not work. Let's go ahead and try -1. Into the same division problem. Bring down the 1. -1 times 1 is -1. Add. -1 times 6 is -6. Add. -1 times 5 is -5. Add to get -8. So that does not have a 0 remainder. It's a -8 remainder. So that one would not be a 0. Okay, let's try 3. Bring down the 1. 3 times 1 is 3. Add to get 10. 3 times 10 is 30. Add to get 41. 3 times 41 is 123. If you add, you're going to get 120 remainder. So that one doesn't work. Okay, so -3 should work. If it doesn't, it means we probably did something wrong. So let's go ahead and try this one. Bring down the 1. Negative 3 times 1 is negative 3. Add to get 4. Negative 3 times 4 is negative 12. Add to get negative 1. Negative 3 times negative 1 is positive 3. You add to get 0. So the remainder is 0. It's a good sign. So the 0 remainder when testing negative 3 tells us that negative 3 is a 0 of the polynomial function there. Now we're going to find all the zeros of that function next. So we found one of the zeros. Now we're going to see if we can find some more. Okay, so again, we're trying to find all the zeros of f that will make this equal to 0. So here was our original. We're going to know when will that equal 0. So we just said that x equals negative 3 is one of the zeros. So the only way you would have gotten that was if you would have had x plus 3 equals 0. That would have given you x equals negative 3. So that means one of our factors is x plus 3. And let's see where that comes from. And the easiest way to do this is to think back to what we just had. We had, when we tested negative 3, we ended up with a 1, a 4, a negative 1, and a 0. And that came from this formula. So that means this would have been x squared, because that's to be 1 less than the x cubed. Then we had a positive 4x minus 1 with remainder of 0. So that means our other factor is x squared plus 4x minus 1. And if you would FOIL and multiply that out, you would end up back with this original equation. And now on the next slide we're going to show, we already know that this 0 would have to be negative 3. So now we're going to have to figure out the 0 of this one. So here are my two factored, and then I set them equal to 0. So this one, we already said we would get x equals negative 3. So on this one, if we tried to find factors of negative 1 that would add to 4, you're not going to find anything. So we're going to have to use the quadratic formula to solve this. So if you remember what that is, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is my a, b, c. So my b, I need to make it a negative 4 plus or minus 4 squared minus 4 times a times c is negative 1 all over 2a, which is 1. So now I'm at negative 4 plus or minus 16. I have a double negative here, so that's just plus 4 all over 2. So I'd have negative 4 plus the square root of 20 over 2. Or negative 4 minus the square root of 20 over 2. Now this one wants you to leave it with a radical sign. So in the past you've done simplifying radicals. So let me try to figure out square root of 20 has a perfect square root of 4 in it, which would leave you with 4 times 5. Square root of 4 is 2. There is no square root of 5, so this simplifies to 2 times the square root of 5. So the way your book wrote it on this one is -4 plus 2 square root of 5 over 2. But then you can simplify this. You could divide this to get -2. Divide this to just get 1. So that 1 you don't need, but it is possible. So this is one of the x's, and the other x would be the same, just with a subtraction sign in the middle. So these are my 3 possible zeros. X equals -3, or x equals -2 plus the square root of 5, or x equals -2 minus the square root of 5. Now I have another one here that I include all the slides. You can walk step by step. So you'll first list all the possible rational zeros, then use synthetic division to test these 4 possible solutions. So on this slide they tested -2 and -1. Neither of those have a remainder of 0. So now we'll test +1 and +2. And this one doesn't work, but this one does, because there's a remainder of 0. So that means this, x equals 2, is one of the rational zeros. Okay, then this was what we got when we did the synthetic division. So this would be our original was x to the 3rd. So this would be x squared. This would be x and 1. So that's where they got that 1x squared plus 3x plus 1 here. And also here. So this came from the x equals 2. You would have had to have x minus 2 to get that. And then x squared plus 3x plus 1 is the other one. So we already knew one of them was x plus 2. Then we had to use the quadratic formula to find the other one. So they plugged that in and ended up getting these 2 answers right here. So your final solution, you have 3 zeros that work. Now sometimes they use an E, sometimes they don't use an E. So I go back and forth. Okay, that is the end of part 1. We'll do part 2 in the next video.